This question is from GATE Mechanical Engineering of 2011. This is question number 15. The question is, a pipe of 25 mm outer diameter carries steam. The heat transfer coefficient between the cylinder and surrounding is 5 watt per meter Kelvin. It is proposed to reduce the heat loss from the pipe by adding insulation having a thermal conductivity of 0.05 watt per meter Kelvin. Which one of the following statements is true? Okay, so these four statements are given to us and we need to find out which is true statement. Okay, now for a heat loss from the pipe, let's draw the graph between Q versus the radius of the pipe. Now suppose the y-axis represent the heat transfer rate and the x-axis represent the radius of the pipe. Now there is something called critical radius at which at that point the heat transfer is maximum. Okay, RC, and it is represented by RC. Now to calculate RC is given by K by H, the thermal conductivity by the heat transfer coefficient. So this we can calculate. K in the problem is 0.05 divided by H is 5, right? So this value will be 0.01 meter. Okay, that is equal to 10 millimeter. Now from here we can see that the critical radius is lesser than the radius of the pipe, right? Because the diameter of the pipe is 25 millimeter. That means the radius is 12.5 millimeter. So the critical radius is lesser than that of the radius of the pipe according to the given conditions. Okay, so if RC is lesser, so adding the insulation will reduce the heat loss. Okay, so if we add more insulation, that means it will reduce. So something, the diameter of pipe that is given is somewhat around here. Okay, so if we add more insulation, we can see that the heat loss will reduce. Okay, therefore the addition of insulation will reduce the heat loss. So option C is the correct choice. For more information, you can refer to the NPTEL course lecture number 23, thermally developing flow through circular pipe with uniform wall temperature, and the consecutive lectures on fundamentals of convective heat transfer by Professor Amrish Dalal of the Department of Mechanical Engineering at IIT Guwahati.